Hello everyone, this is Purnima serving as Assistant Professor in the Department of Electronics and Communication Engineering at SNS College of Technology. In this video series, we will discuss about the course Analog Communication. And today we are going to discuss about the topic Double Sideband Suppressed Carrier, that is DSBSC modulation. What's the reason for going DSBSC instead of conventional AEM method? So in conventional AEM method, we have an unused portion of the carrier. This will lower the power efficiency of AEM modulation technique. So that's the reason we are choosing DSBSC. So in this DSBSC, the carrier is suppressed. And the definition, in the DSBSC, only the upper sideband and the lower sideband of conventional AM is transmitted, and the unused portion of the carrier is suppressed, is so-called the DSBSC, double sideband suppressed carrier modulation technique. And the block diagram as follows. The input to the any modulator is one is modulating signal, that is our low frequency message signal, which we need to transmit to the receiver. And the next one is high frequency carrier, which will be the carrier will be carry the modulating signal. And the resultant signal is modulated signal, that is DSBSC signal. Here in the DSBSC modulation, simply the product modulator does the operation of DSBSC modulated signal output. And we'll see the representation of DSBSC waves. And the first signal is nothing but our message signal, that is low frequency signal. Here you can see the time duration of one cycle is very large when compared to the carrier signal. Hence, it is a low frequency signal. And the next one is a high frequency signal, carrier signal. And the third one is DSBSC modulated output signal. Here you can see only the upper sideband and lower sideband. There is no middle unused portions. So hence it is called as DSBSC signal. And we'll see the time domain analysis of DSBSC way. Let us consider two input. One is modulating signal and another one is carrier signal. Modulating signal M of T is represented as AM cos omega CT as a cosine wave, and it's a low frequency. And the next one is carrier signal C of T. AC cos omega CT. Here omega C is always greater than omega M, so that modulation is possible. And the DSBSC modulated signal S of T simply follows a product of M of T and C of T and results the DSBSC signal as follows. That is nothing but AC M of AC AM by 2 cos of upper sideband plus lower sideband, nothing but omega C plus omega M gives the upper sideband. Omega C minus omega M gives the lower sideband. That is nothing but frequency translation to higher frequencies. So here you can see there is no carrier component, and the third component that is presented in the AM is suppressed in this DSBSC. So it is called as in the way it is producing a power efficiency when compared to AM modulation. And the next we'll see power analysis. So in the conventional AM, it has three components. One is a carrier and the upper sideband and the lower sideband. So we need to include all these three components in the power calculation. In this DSBSC, we have suppressed the carrier signal. So the remaining is only upper sideband and lower sideband. This will give the power that is the total power of DSBSC will be mu square by 2 into PC. Here mu is nothing but the modulation index. Next is power savings. So we know that why we are coming from AM to DSBS is to increase the power efficiency. So how much amount of power is saved is given as power efficiency formula. That is nothing but percentage of power savings is equal to AM power minus DSBSB power divided by AM power. So this will be calculated as 100%. So this will end up with the formula 2 by 2 plus mu square into 100%. When you do mu is equal to 1 for perfect modulation, and the power efficiency will be around 66.7% in the case of DSBSC. But in the case of AM, this will be around 33% only. So this way we can improve the power efficiency. And the next one is bandwidth calculation. So in the DSBSC, the wave has two components, upper sideband and the lower sideband. Therefore, bandwidth will be upper sideband minus lower sideband. This will end up with the result 2 FM. It is same as the AM. So AM also having the bandwidth of 2 FM only. We'll see advantages and disadvantages of this modulation technique. When compared to AM signal, in DSBSC, the power is saved by suppressing the carrier, but the disadvantage of this technique is that AM and DSB both having same bandwidth, that is 2 FM. So there is no power bandwidth efficiency. This is the main drawback of using DSBSC. Thank you.